Now, ultimately, what we have to be able to do with these acid-base equations is we have to decide what's the acid, what's the base, what's the conjugate acid, and what's the conjugate base. Okay, now the way it works is, let me go ahead and put down a acid-base reaction, and let's say we have hydrogen iodide plus water. And we're going to put a double arrow here, which means that it's in some sort of equilibrium, which means it has a forward reaction and reverse reaction. And we're going to produce I minus plus H3O plus. Now, as we've seen earlier, if you have an H in the front, such as HI, that's probably an acid. But the way we decided is if you lose a hydrogen, then that made you the acid. And if you gained a hydrogen, that made you the base. And so if we look here at HI, we see that we have lost an H going from HI to I, and so that makes HI hydroiodic acid. It makes it a proton donor. So this was the acid for sure. And as we go from H2O to H3O plus, then we gained a hydrogen. We went from H2 to H3, so that made H2O the base. And of course, anytime we have an acid or base reaction, the acid is always on the left-hand side. The base is always on the left-hand side. So never put them on the right-hand side. However, now here's where the conjugate acid, conjugate base comes in. If you look, you will see that as you go back in the other direction with the arrows, the I going to HI in the other direction, the green line, well, you go from no hydrogens to one hydrogen, so going backwards in this equation, the I has accepted a hydrogen to go to HI. Now, the definition of a base is a proton or a H acceptor. And we can't call it a base on the right-hand side because, like I told you, the acid and base are always on the left. So what are we going to call it? Well, going back in the other direction, we're going to call this the conjugate base. And the conjugate acid and base is always on the right-hand side. And as you look at, as it's going from right to left instead of left to right. And so the I minus, the iodide, going to HI has accepted a H, and that makes it a base. And similarly, for the H3O plus, the hydronium, as it goes from right to left back to that water, what does it do? It loses a hydrogen. It goes from H3 to H2. So if you lose a hydrogen, that makes you an acid. But since it's on the right-hand side, we're going to call this the conjugate acid. Okay? So what's the rule? The rule is if you're on the left, if you're going from left to right, then if you gain H, that makes you a base. And if you lose H, then that makes you an acid. And then for the conjugate is always going right to left. Okay? And it's the same sort of situation, except now we say if we gain a hydrogen going back in the other direction, we call that the conjugate base. And if we lose a hydrogen going from right to left, we call that the conjugate acid. And so we can look at any equation. All we have to look at is count the hydrogens. And which way are you going? If you're going to the right, then you're either going to be an acid or base. You're either going to lose a hydrogen or you're going to gain a hydrogen and make you a base. Or if you're going from right to left, you have to say conjugate, and that's always on the right-hand side. Same sort of situation. If you gain a hydrogen going from right to left, that makes you the conjugate base. And if you lose a hydrogen going right to left, that makes you the conjugate acid. So let's do one more example. And I'm doing these out of the textbook. Let's say we have the carbonate ion, all right, with water. And it's in an equilibrium. There it is, back and forth. And it goes to bicarbonate ion plus OH minus, the hydroxide. So what's the acid? What's the base? What's the conjugate acid? What's the conjugate base? And so we just count hydrogens. So here's one way to do it. I have no hydrogens here. I have 2 hydrogens there. I have 1 hydrogen over here and 1 over here. And let's connect them. How are they connected? Well, let's see, the carbonate goes to the bicarbonate. It went from 0 to 1. It gained 1 hydrogen going from carbonate to bicarbonate. So that makes the carbonate, in this case, the base. And we do the same thing with the H2O. We went from 2 to 1. Well, that means we lost a hydrogen going from H2O to OH. And so that makes the water an acid. Okay, now we got to look on the other side. And similarly, what we're going to do, and we'll draw this in green, is we're going to go from right to left with the bicarbonate to the carbonate, and it loses a hydrogen going from right to left, so we call that an acid. And we can do the same thing with the OH minus going in the other direction, and we go back to the water, and we gain a hydrogen, so that makes the OH minus the conjugate. Don't forget the conjugate part, the conjugate base. Okay, now practice is perfect on this, but basically you're counting how many hydrogens you gain or lose out of the molecule from one side to the other. So that's how you do identifying the acid base, conjugate acid, conjugate base. So if you were given just a simple, just a compound, and you said, well, I have carbonate and we want to know what's the conjugate acid, well, you would add 1 hydrogen to it. So we would add an H to make it the conjugate ace, because that's what conjugate acid, because that's what's happening up there. And so the conjugate acid would be HCO3 minus, which is the bicarbonate ion. Similarly, we could do that with just about anything. Let's say that we have NH3 ammonia, and I want to know what's the conjugate acid. Just add another hydrogen. But you also have to make sure you're adding H+, so that's going to be not just NH4, but NH4+, because after all, we're adding or taking away H pluses. Similarly up here with the carbonate, you see how a 2 minus, now we have minus. That's because you added a plus. And we can also do things like what's the conjugate base. And so if we had something like, say, water, what would be the conjugate base? Well, in that case, we would take away a hydrogen, but keep in mind that we're taking away H+, so it would become negative. And if I take 1 away, we have the hydroxide ion. So the bottom line is you just need to be able to count the number of hydrogens that you're coming from or going to.